Hello everyone, today we'll be talking about section 8.4, misleading graphs. Okay, so there are ways for graphs to be represented misleadingly. For example, displaced axis, that means the numbers on the axis do not start at 0. And then we can also have irregular scale. So the space between the numbers on axis is not constant. For example, if you have, let's say, 1, 2, and then suddenly 3 over here. So you can see that the space is not the same. Okay, and then we can also have exaggerated use of area and volume. So let's say the height and or the width are exaggerated by using areas and volumes. So you may have bigger pictures or bigger diagrams of something. Okay, and then here's a break. A break in the y-axis of the graph means the length of the axis has been shortened. Okay, so for example, normally we'll start from, let's say 0 and then 1, 2, 3, 4. And with the break here, it's saying that, oh, okay, we start from 0, but because the first point is at, let's say, 50 and then 51, etc. So they break it so that so that instead of 0, 1, 2, 3 up to 50, they start from 0 and then the first point is 50 and then let's say 51, 52, etc. So they basically have um, ignored the measures between 0 and 50. Okay, so let's do some examples together. Okay, first example here, this graph. What is your first impression of the graph, and what does it suggest about Matthew's test score over the last 4 tests? Okay, well, you can see from here to here, well, he has really improved a lot. So our impression is he has improved a lot. Now, looking at this graph closely, it's actually starting from 0, but with a break here. So the break here ignored the value between 0 and 60. So really what the graph should look like is this. So here you had a break so that the graph is misleading. And how would you make the graph less misleading? Well, you will use the normal scale. So from 0 and then 10, 20, 30, etc. up until 70. And so if we draw the test score number 4, let's say this is 60, and then this is 65, this is 68, this is 69. So if we draw this one, it will look like this. So this is 69, 68, 63, 60. So if you're looking at this graph, really he has improved, but not that much, right? But the first misleading graph will give you the impression that he has improved a lot. So how could you make the graph less misleading? Well, we can do that by starting from 0. Okay. All right, next example. So example number 2. Here's a pictogram, and from the pictograph, which pet seems to be the favorite? Explain. Well, just by looking at this graph here, we'll say that the fish is more is the favorite, and because it's the biggest, it's bigger than the others, bigger than the other pets. Well, but if you look at the representation here, really each of the picture represent 10 students. So it's not really the favorite. It just look bigger. So how can you redraw these data so that they are more accurate? If we want to make them more accurate, you want to make them the same size. Size. So a cat, and then the second one is a dog, and the last one is a fish. This one's a bit too big. Let's draw smaller. So something like that. They have to be the same size so that you can compare them. Okay, so that they're not that misleading. Okay, now is our no. Let's look at our third example. By looking at this graph, we know the computer sales for desktop is 4,000 and for laptops is 2,000. So the first question, how many more desktops were sold than laptops? Well, how many more? So we've sold 4,000 desktops and 2,000 laptops. So it's 2,000 more. 2,000 more. And does graph A shows the data accurately? Yes, of course. It starts from 0 and each of the scale is correct. It's not misleading. The bar is of the same size, so yeah, it shows the data accurately. Now, if we look at the second graph, graph B here, has the number changed? Well, not really. It's 4,000 and it's 4,000, sorry, 2,000 here as well. But it's misleading because the bar for laptop is double the size. So even though they have the same data, but the size of the bar is doubled. So it seems like that we've sold a lot of desktops when it's really not, when it's really just that 4,000, right? So it's misleading in the sense that it's the size of the bar is doubled. So it's exaggerated use of area. Okay. And last example, number 4. Okay, so we have Vanessa's math marks and Hayden's math marks over the 4 terms. So the first question is, which line graph appears to show a greater increase in marks from term 3 to term 4? So from term 3 to term 4, this is term 3, this is term 4. It looks like that. Which one shows a greater increase? Well, of course, Hayden's increase is steeper, so we'll say that Hayden has a greater increase in marks. Now let's calculate for B, let's calculate the actual increase in marks for each student. Okay, so this mark is 75, and this is 90. This one is 68 and 80%. So the actual increase then is going to be for Vanessa. For Vanessa, it's 90 minus 75, which is a 15% increase. So 90%. And then for Hayden, it's 80% minus 68%, which is a 12% increase. So really, Vanessa has a greater increase than Hayden. And so why do you think this graph is misleading? Where do you think uh, the misleading part is? Well, it's this part. You have a break here. Well, it's the break. Because you're not starting from zero, not like this one. So it seems to be a greater difference between the two values or two data. Now, how do you change the graph so they are not misleading or so they don't misrepresenting the data? Well, we can do two things. First one is we can remove the break. And we can have the same scale in the vertical axis. Same scale as the first graph. Okay, so that's it for today's lesson. Please try all of the questions in 8.4 and let me know if you have any questions or problems.